Here we're doing the first half of the multiple choice portion. And so the first question, which measurement shows the temperature to the correct precision? Okay, well we can see a line right here, and that line is for 26 degrees, and that line's for 27 degrees. So we're sure to the ones place, so we need to go one more place, and so we're going to say it's 26.3 degrees, answer C. Scientific notation, okay, the decimal point is after that last zero. We want to make a number between 1 and 10, so we need to move the decimal place over 6 places. So that's going to be 3.02 times 10 to the 6th. Anything with a 10 to the negative is going to be less than 1. This is much larger than 1. Okay, this problem here is not a calculation problem, as it's a significant figure problem. So we see that this number has 3 significant figures, that one has 3, that has 3, this has 4. So our answer is going to have 3 significant figures. So if we look at all of our answers that we have here, we can eliminate that has 4. We can eliminate that has 2. And we can see our numbers 1, 1 over 0.08 and 300. This is definitely going to be a smaller than 1 answer, so it has to be answer A, not answer D. Okay, most precise. Most precise is the one with the smallest plus or minus value, so there's the smallest wiggle in the numbers. They're closest to each other, so that has to be answer B. Okay, density of copper is known to be 8.96, so that's our known value. And the student's experimental result was 8.79. What's the percent error? So we want the difference. How far are they off? So I'm going to say 8.96 minus 8.79 divided by what is supposed to be 8.96. And this will all be times 100%. And when we get down, the answer comes out to be 1.897. So that rounds up to 1.90. Okay, the average temperature on Venus, 460 Celsius. How do we do that to Kelvin? We have to add 273. Kelvin numbers are always larger than Celsius numbers, and so that comes out to be 733. The formula for this, if you forget, is given on the test, so go look it up. Which of the following statements is true? Okay, which is true? So we're looking, when we cross out the false ones. There are not 1,000 centimeters in a meter, there's only 100. And there are, 1,000 millimeters in a meter, so that's wrong. Okay, C is correct. Which conversion factor would you use to convert milligrams to grams? This is the kind of problem where I would start off with milligrams, just to make a problem for myself. And if I want to go from milligrams to grams, I want to use something like this. And I know that grams are bigger than milligrams, so there'd be 1,000 milligrams per gram. So I'm looking for that answer, and that answer looks like letter B. Okay, a metal cube measures 2 centimeters on the side, and its mass is 90.4. What's the metal? And so we're given the densities, so we really want to figure out the density. So density is mass over volume, and in this case, since it's 2 centimeters on each side, it's length times width times height. So we're looking for an answer to 90.4 grams over 2 times 2 times 2, which is 8. So 8 goes into 90, 8 goes into 80 10 times, so it's a little bit bigger than 10. So we're looking for answer D. It's the only reasonable answer. Number 10, what's the volume of a 5.08 gram sample of the liquid bromine, and the density is given? Density can be a conversion factor. So we'd say 5.08 grams. And we say there's 3.10 grams per milliliter. So what I'm looking for is 5 divided by 3, which is greater than 1. It's just a little bit greater, like 1.5. So the answer must be B, 1.64. And in fact, it's 1.6387. Okay, a gold block and a copper block have a mass of 5 kilograms. Okay, density. Gold is more dense than copper, so that means it's more compact. So the answer here, which has a greater volume? Well, If it's more compact, it would have a smaller volume, so the copper block is the one that would have the greater volume. Now, cobalt, I looked it up on the periodic table, and cobalt is number 27. So I know it has 27 protons, so we can eliminate the answer D. It has 57 as mass, so 57 minus 27 means it has 30 neutrons. So I know that that's not the correct answer. And it's a 3 plus charge. If it's 3 plus, it means it must have more protons than electrons. So it can't be 30 electrons, that would be negative, so the answer is A. All of the following describe a neutron except, now be careful about these negatives. So who does, talk about a neutron? Those are not the answer. So it determines the identity of the atom. That is not true. That is the answer. That's a proton. Let's double check. It does not carry a charge. That's true. So that's not our answer. It's located in the nucleus. That's true. It, along with the proton, makes the most of the atom's mass. That's true as well. So the only one that is not true is answer A. Which of the following is an isotope? Isotope is the same element with a different mass. Same element with a different mass. So those are different elements. They can go away. This one has the same mass, so it's answer A. So the isotope of K40 would be K39. Okay, the atomic mass of aluminum is 26.98. That's the average of all the different isotopes. So which is correct? One aluminum atom has a mass of 26.98 AMUs? No. Okay, that would be the average of the different isotopes. Any one atom would not have that mass. One aluminum atom has a mass of 26 grams? No way. Okay, 1 mole contains 26.98 atoms? No, that's not right. So that's not right. So it must be D. Okay, 1 mole of aluminum has a mass of 26.98 grams. 16. In which of the following states of matter are the attractive forces the strongest? Okay, solids definitely can be held together more strongly than liquids or gases or plasma. Which consists only of elements, okay, elements as opposed to ions or compounds. So those have ions, that's got compounds, that has compounds. So the answer, the only one that has elements, could be diatomic, but is A. What do elements phosphorus and sulfur? Okay, look them up on the periodic table. They're right next to each other. So phosphorus, sulfur. Okay, they're both alkali metals. No, neither are alkali metals. They're in the same family. No, that would be the same column. They are in the same period, and they don't both form the same ions. Phosphorus is 3 minus, sulfur is 2 minus. 19. Which of the following is a liquid non-metal? Well, liquid could be mercury, but that's a metal, so that's not the answer. Barium would be a solid, nitrogen would be a gas. Bromine, mercury and bromine are the two liquids. Which of the following is ionic? Ionic, so we need a metal and a non-metal, like answer A, aluminum chloride. B is an acid, and these are non-metal compounds. 21. Which is the formula for the ionic compound formed when sodium ions, that's Na+, and sulfide ions, that's S2-, and we know that just from their positions on the periodic table. So we're looking for Na2S, answer A. An unknown element X forms a salt with XO2. Okay, so we got X, and we know that oxygen is 2-, and if it's XO2, that means it must be 4+. So the only possibility is answer D. Which of the following is correct formula for calcium phosphate? Okay, we know calcium is Ca2+, because we memorize it, or we can see it on the periodic table. Phosphate is PO4 3-, because we memorize. So calcium phosphate must have 3 calciums and 2 phosphates, and that looks like answer B. What's the name of this compound? Nitrogen and oxygen, those are both nonmetals, so we need a di-tri sort of a thing. So dinitrogen trioxide, not nitrate or any others. Sulfuric acid, hydrosulfuric acid. So hydroic acid means it must end in "ide." And so we are talking about sulfide. And sulfide is S2 minus. So we want the compound S2 minus H2S right there. Which of the following is incorrect? Incorrect. Be careful. So we want to get rid of things that are correct. 1 mole of oxygen molecules has 6.02 times 10 to the 23 oxygen atoms. That's our answer. That's incorrect. You would have 6.02 times 10 to the 23 oxygen molecules, which would be double that number of atoms. Let's double check. A mole of oxygen has a mass of 32. That sounds good. A mole of O2 occupies 22.4 liters. That's good. And all the above statements are correct. That is not correct. So you could actually make an argument about D being the answer as well, but I'm sure we mean A is the answer. 27. How many molecules are in 2 times 10 to the minus 2 moles of carbon tetrachloride? The molar mass 154. In this case, we do not need the molar mass because we're not doing anything with grams. So how many molecules in 2 times 10 to the minus 2 moles? So 2 times 10 to the minus 2 times 6.02 times 10 to the 23. So what are we going to have? 2 times 6 is going to be 12 times 10 to the 21, which would be 1.2 times 10 to the 22. Okay, the percent carbon in barium carbonate. Well, there's 1 carbon, and that's going to be 12 grams over the total 197.3 times 100. And if we work that out, that comes out to be the 6.09, 6.087. Okay, last few. The general formula CnH2n describes what? It describes the alkenes. The alkenes. Alkanes are 2n plus 2. Alkynes are 2n minus 2. Alkadienes would be something where there is 2 double bonds in the molecule, and that would have the same formula as the alkynes. Structural formulas have advantages over molecular formulas because they show the bonding arrangement of each carbon atom. That sounds good. Geometric arrangement of the atoms. That sounds very close. The number of atoms of each element present. That's not the answer because that's the same in the molecular and structural. The percent composition, that's going to be the same in structural and molecular. So bonding arrangement or geometric arrangement. And the answer here is the bonding arrangement, because the geometric arrangement implies you're getting the right bond angles. Okay, and you don't get the right bond angles, just like the picture here below on number 31. All those carbon bonds look like 90 degrees, and they are not. But we can see who's connected to who. Okay, 31. How many carbon atoms make up the parent chain? So the parent chain is the longest continuous chain of carbons, and in this answer it's 6. And remember that the parent chain can go around corners. Now the number of isomers of bromopropane. So H7Br, that's like C3H8. That means everybody is going to be a single bond. And where can we put that bromine? Okay, the bromine could go here, 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 and that would all count as 1 bromopropane. Or we could put it here and here, change colors, and that would count as 2 bromopropane. So the answer is that there are 2 isomers of bromopropane. And that's the end of this section of the practice test.